Have you ever pondered on what lies beneath our feet? Let's take a journey downwards, embarking on an exploration of the Earth's outermost layer, the crust. This is where we live, where we build our homes, grow our food, and conduct most of our activities. But there is much more to it than meets the eye. The Earth's crust is a complex and fascinating structure. It's not uniform or flat, but varies in thickness. Picture this. Beneath the vast blue oceans, the crust is at its thinnest, averaging about 5 miles in depth. But beneath towering mountain ranges, it can extend up to 70 miles deep. That's a bit like comparing the height of an apple to the height of a 15-story building. Now let's dig a bit deeper into what the crust is made of. It's a treasure trove of rocks and minerals. There are 3 main types of rocks found here: igneous, sedimentary, and metamorphic. Igneous rocks like granite and basalt are formed from cooled, hardened magma or lava. Sedimentary rocks like limestone and sandstone are formed from the accumulation of tiny pieces of other rocks or organic material. And metamorphic rocks, like marble and slate, are formed under the surface of the Earth by intense heat and pressure. If you missed our last video, click the link in the description box or the link on the screen right now to watch Rock Solid Secrets to learn more about rocks on Earth. Beyond rocks, the crust is also rich in a variety of minerals. You might be familiar with some of them, such as gold, silver, and diamonds, but there's also quartz, feldspar, mica, and many others. These minerals not only provide us with precious gems and metals, but also play a vital role in our everyday life, from building materials to the components in our electronic devices. So, the next time you take a walk outside, remember, you're walking on the Earth's crust, a layer of immense geological and biological importance. And this is just the beginning of our journey. Stay with us as we delve deeper, past the crust, and into the Earth's mysterious interior. What if we go deeper, past the crust? What would we find? As we journey beyond the crust, we would find ourselves in the Earth's mantle, the thickest layer of our planet, spanning about 1,800 miles. The transition from the crust to the mantle is marked by a significant increase in pressure and temperature. This boundary is known as the Mohorovičić discontinuity, or simply the Moho, named after the Croatian seismologist who discovered it. The mantle is composed mainly of silicate rocks, rich in iron and magnesium, giving it a dense and semi-fluid consistency. The temperature here ranges from approximately 1,000 degrees Celsius at the top to a staggering 4,000 degrees Celsius at the bottom, near the core. This intense heat causes the rocks to melt and behave like a very thick liquid, moving in slow churning motions. Now here's where things get interesting. The uppermost part of the mantle, along with the crust, forms what's known as the lithosphere. This rigid layer, about 62 miles thick, is broken into massive plates. These tectonic plates float on a softer, more fluid layer of the mantle called the asthenosphere. The asthenosphere is a fascinating place. It's here that the semi-fluid rock of the mantle moves in a circular motion due to heat. These movements drive the drifting and colliding of the tectonic plates above, leading to earthquakes, volcanic activity, and the creation of mountain ranges on the crust. If you are interested in learning more about tectonic plates, click the link in the description box below or the link on the screen right now to watch our previous video, Shifting Secrets, Living on Plates. So, the mantle isn't just a layer of hot, molten rock. It's a dynamic, ever-changing realm where the heat of the Earth's interior meets the rigid crust, shaping and reshaping our planet's surface in a ceaseless dance of creation and destruction. The Earth's mantle, a dynamic and ever-changing layer, plays a crucial role in shaping our planet's geological features. Our journey to the center of the Earth continues, and next, we're heading to the core. Now, let's venture into the deepest part of our planet, the Earth's core. This extraordinary region lies beneath thousands of miles of crust and mantle, encapsulating the very heart of our home world. The core itself is divided into 2 distinct parts: the outer core, which borders the mantle, and the inner core. The two have different characteristics, and play different roles in the functioning of our planet. The outer core, a sea of molten iron and nickel, is about 1,300 miles thick. Its swirling, liquid nature is a result of the intense heat that exists at these depths, which prevents the metals from solidifying. This is where the magic happens. The movement of this molten metal generates our planet's magnetic field, creating a protective barrier that shields us from harmful solar radiation. It's our planet's very own force field, if you will. Now, if we delve even deeper, we reach the inner core. Unlike its outer counterpart, the inner core is a solid ball of superhot iron and nickel. It spans around 750 miles, and despite being under immense pressure, remains solid because of the chilling fact that it's hotter than the surface of the sun. Fun fact, the center of the sun is actually hotter than the Earth's core. The core's extreme conditions, with temperatures reaching up to 9,200 degrees Fahrenheit, and pressures millions of times greater than at sea level, make it a place of mystery and intrigue. It's a region that no human, probe, or even advanced technology has managed to reach or accurately picture. Our knowledge of the core is based on seismic data, as the waves from earthquakes change speed, direction, and form when passing through different layers of the Earth. Studying the Earth's core is a challenge, to say the least. Its inaccessibility makes it one of the most difficult places to study, but it's also one of the most important. The core is the engine that drives many of Earth's most dynamic processes. It's responsible for our magnetic field, and its heat powers the movement of tectonic plates, leading to phenomena like earthquakes and volcanic eruptions. Despite the challenges, scientists are endlessly striving to uncover the secrets of the core. Each new discovery brings us one step closer to understanding the inner workings of our planet, and perhaps even the workings of other planets too. So as we stand on the Earth's surface, it's fascinating to imagine the intense fiery world that exists thousands of miles beneath our feet. It's a reminder of our planet's dynamic nature and the incredible forces that shape our world. Despite its mystery and inaccessibility, the Earth's core holds the key to many of our planet's most fascinating phenomena. So we've ventured from the crust through the mantle and into the core. What have we learned? Our journey began on the outermost layer of our planet, the Earth's crust. This is the layer we interact with daily, where we build our homes, grow our food, and extract valuable resources. It's a relatively thin layer, varying from roughly 3 to 45 miles in thickness. Despite its thinness, the crust is home to a rich variety of rock types, minerals, and life forms. Next, we traveled through the Earth's mantle, plunging deeper beneath the surface. The mantle, making up about 84% of Earth's volume, is composed of silicate rocks rich in iron and magnesium. It's a realm of extreme temperatures and pressures, where rocks slowly flow and deform over geological timescales. This layer is the engine room for Earth's tectonic activity, driving the movement of the crust and shaping the surface of our planet. Finally, we journeyed to the Earth's core, the deepest and most inaccessible part of our planet. The core, divided into an outer liquid layer and an inner solid layer, is a world of intense heat and pressure. Here, temperatures can reach over 9,000 degrees Fahrenheit, hotter than the surface of the sun. The churning of the liquid outer core generates Earth's magnetic field, a protective shield that defends our planet against harmful solar radiation. The Earth's layers are not isolated from each other. They interact in complex ways, influencing each other's behavior and contributing to a range of geological phenomena. For instance, the heat from the core and mantle drives the movement of tectonic plates in the crust, leading to earthquakes, volcanic activity, and the creation of mountain ranges. The journey from the Earth's crust to its core is a fascinating exploration of our planet's complex and dynamic interior. So the next time you step on the ground, remember the incredible journey that lies beneath your feet. Our journey into the Earth's depths has been quite a ride. As we've seen, each layer of our planet holds its own unique mysteries and marvels, from the crust that supports our daily lives, to the mantle where fascinating geological transformations occur, and all the way down to the fiery core, the heart of our Earth. It's been an absolute pleasure having you join us on this subterranean expedition. The wonders of our planet do not stop here, though. There's so much more to learn, so much more to explore. From the highest mountains to the deepest ocean trenches, the Earth never ceases to amaze and inspire us. So keep that spark of curiosity alive. Keep asking questions, keep seeking answers. Because when it comes to our planet, there's always something new to learn, always something incredible to discover. Remember, there's always more to discover about our incredible planet. If you made it this far in the video, thank you for your continuous support. If you learned something, like this video and subscribe to our channel for more content.